Hello everyone, in this video we are going to solve question number 9 of exercise 6.2. The question says ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at O. You have to show that AO upon OB is equals to CO upon DO. Means you have to prove that the diagonals of this trapezium intersect each other, or you can say cut each other proportionally, because here the ratio between this AO and OC is equals to the ratio between OB and OD. Means these two diagonals are cutting each other in equal ratios, and when two things are in equal ratios we say that those things are in proportion. So here we have to prove that the diagonals of a trapeziums cut each other proportionally. So if I interchange this CO with this BO, means I'm multiplying this BO that side and I'm bringing that CO this side. So here you have to prove this, that the ratio between AO and OC, this is OC, is equal to the ratio between BO and OD. BO and OD. So you have to prove this. To prove this, we have to do a construction here. We have to draw a parallel line to this DC from this point O. So I have to draw a parallel line, say OL, which is parallel to this DC, and AB is given parallel to this DC, and I have drawn this OL parallel to this DC. So clearly all three lines must be parallel. This line is parallel to this line and this line is parallel to this line. So these two lines must also be parallel. This we have already known, or you can say we have already studied this in the previous classes. Now if I draw this triangle BDC, this is triangle B, this is D, and this is C. This is this triangle BDC, and in this triangle a point on this BD, which is point O, I have drawn a parallel line which is OL, and this line is parallel to this DC. And according to basic proportionality theorem, if a line in a triangle is parallel to this third line, then it must divide the other two lines in equal ratios. Means if this line is drawn parallel to this third line, it must cut the other two lines in equal ratios. So in triangle, this is triangle BDC, in triangle BDC, OL, before this we have to write that we have constructed line OL which is parallel to DC. Then after you have to write that in triangle BDC, OL is parallel to DC. Therefore, it must cut the other two sides in equal ratios. Means the ratio between BO and the ratio between OD must be equal to the ratio between BL and the ratio between LC. So this is because of basic proportionality theorem, and this is our first equation. And now we have to apply the same theorem in another triangle, which is ACD. If I draw this triangle, it looks like this. This is A, this is B, and this is C. And in triangle ABC, this OL is parallel to this AB. So again, according to basic proportionality theorem, if I draw a parallel line to this third line, it must cut the other two lines in equal ratios. Means the ratio between this and this must be equal to this upon this. So in triangle this is ABC, this OL is parallel to this AB. I have already discussed that how OL is parallel to AB, because we have drawn OL parallel to DC. we have drawn this OL parallel to this DC, but this OL must also be parallel to AB. Now if these two lines are parallel, it must cut the other two lines in equal ratios, means the ratio between that CO upon OA must be equals to the ratio between CL upon LB. So this is again because of basic proportionality theorem. This is our second equation. Now first of all, I have to reciprocal this equation so that our proof will be easy. So I can write that OA upon OC is equals to, this is LB upon LC. Now I have, this is our equation, this can be considered equation second. I have reciprocal this. Now if I compare equation first and equation second, in that case this BL upon LC, here this BL upon LC are same. So if the right hand side of the equations are same, so clearly the left hand side must also be equal. So we can say that this is AO. Comparing equation first and second, comparing equation first and second, we can conclude that ratio between AO, which is this AO upon CO, this is CO, must be equals to ratio between this, which is BO upon OD. So we can conclude that the ratio between these two are same. Again, if I cross multiply these two things, this will give AO upon BO. This can be multiplied here, and this CO can be multiplied that side, and this is equals to OD. So this is same as this value. So this is how you can prove this question number 9th, and I hope you have understood how to solve this question. And if you liked this video, please subscribe to our channel. And if you have any problem in maths, you can directly contact to us. The phone number, the WhatsApp number and the email address is given below in the description. Thank you.